This is Kevin Cofield with Cofield Aviation. In this second video, we're also going to explore model data, pivotalweather.com, Skew-T diagrams, but we're going to do it more in a format of flight planning up to 3 days in advance when the models really become much more accurate. So let's get started and look at that. So we're going to go to pivotalweather.com. It's going to pull up the home page here. And we're going to zoom in and we're going to find where it says models, and we're going to select models. And it's going to bring us the same page here that we looked at in the first video, if you've seen that. But we've got three items up here at the top. We've got model, we've got the zoom, and we've got animation. So there's a multitude of models. If there was one model that worked for that was accurate all the time, we'd only need one model. So these are computer generated models. There's tons of models out there, but I'm going to kind of show you what I use in planning a flight in close proximity up to 3 days in advance. So we're going to select a model here, and I'm going to start with the convection allowing. So these are high resolution data, where it almost looks exactly like a radar picture. So I'm going to use the NAM CONUS is what I'm going to start out with. And we're going to plan the same flight. We're going to act like we're doing Gadsden down to Orlando. We want to make sure that we're looking at the latest model. And we're going to zoom in here to the run. And we've got a run of 18Z. But if you look, this one only goes out 9 hours. We're going to plan a flight. This is a Saturday. We're going to plan a flight as if we're leaving, Sunday afternoon. So 1 day away to tomorrow afternoon. So 9 hours away is not going to do it. So what we can do is we can hit this run, and we can go to 12Z, back it up one, and if you look, now it goes up to 60 hours in advance. So we're going to use that model run for this planning. Secondly, we want to scroll down here, and in this menu, right now we're looking at the temperature. I want to look at the precipitation type. So if you see this precipitation type, reflectivity with precip type, I'm going to click that, and that's going to bring up our radar looking type page. Now, we're just looking for Gadsden to Orlando. We're not needing to see the entire continental United States. Now, if I was flying from one part of the country to the other, I would leave it right here. But I want to zoom in on just the southeast. So with this zoom, I'm just going to click that. I'm going to go to regional, and then I'm going to click the southeast down here. That's just going to zoom in on the southeast. Last, I'm going to go here to the animation, and I want to go to the forecast loop, which is right there. So these three parameters, we've got the NAM CONUS model, what we're looking at. We've zoomed into the southeast, and we've got it on the forecast loop where it gives us a slider up there that we can look at. So again, this is a Saturday. Looking at a flight for Sunday, let's just say Sunday afternoon, maybe 21Z. Remember, everything is in Zulu time, which we know as pilots. So we're going to look at Sunday at 21Z and see what the weather looks like for a make-believe flight here to Orlando. So again, we've got not the latest model run, because the latest model run would be 18Z. It only goes out 10 hours. So if you see here, I'm going to zoom, do this slider, and it's only going to go out till Sunday at 0600Z. So that's not going to get what we're looking for. So we're going to step it back one run to the 12Z, and let's find what it looks like for Sunday at 21Z. So I'm going to slide this till we get to Sunday, and there is Sunday at 21Z. So on the surface right here, looks like the flight to Orlando would be precipitation free. Not any thunderstorms, convective activity, rain, or whatever. So now we want to look at where's the clouds going to be? Can I make this trip VFR, or if I'm an instrument rated pilot, where are the clouds going to be? Do I have any icing conditions? Or in cruise, am I, going to be above a cloud layer? So for the flight, I might have to climb through a layer, might have to descend through a layer. So let's walk through that and see what that looks like. So I'm going to zoom in on Gadsden, and I'm just going to click on the screen. That's going to bring up something called the Skew-T diagram. Now, in the Skew-T diagram, we're only going to pay attention to right here. So the red line is the temperature line. The green line is the dew point. Now, we as pilot, when we know that when temperature and dew point get close together or the same, then we're looking at clouds. In this instance, you see the temperature line and the dew point are very far from each other. That means there's going to be no clouds at all. So it's a sky clear condition, which is good. Bottom right here is going to be the wind speed. So we got wind barbs right there, and this is the velocity. So before we go much further, this is the altitudes that we're looking at. So the 1,000, the 850, and the 700, that's all millibars. So that's pressure. As we know, at sea level, we're kind of sitting at the bottom of the pool, so we got the most atmosphere pressure, the weight of the atmosphere on top of us. That's why the lines 850 to 1,000 are closer together here, and then as you go up in the atmosphere, they get further and further apart because there's less weight and less volume. So the 1,000 millibars is about sea level. And if you see the red, that's the kilometers there. So 1 kilometer, 3 kilometers, that's giving you altitudes above sea level. The 850 is approximately about 5,000 feet. The 700 is approximately 10,000 feet. So we're going to be looking in this range to determine cloud height. Now, obviously, with the temperature and the dew point not close together, there's no clouds whatsoever. We'll look at an example here in just a minute where they come closer together so you can see that. But again, 700 is about 10,000 feet, 850 is about 5,000 feet, 1,000 is about sea level. As we go up here, 500 is around 18,000 feet, the 300 millibar is around 30,000 feet. And again, you can see the kilometers there, so you could convert that over to feet with a calculator if you need to. So coming back over here, the orange lines that are going north to south there, that's the wind velocity. And that first line is 20 knots. So we're looking here at this first wind bar. That's going to give you surface winds. And the surface winds are going to be out of the west, southwest at 10. So the barb there that we saw in weather information videos, that one barb equals 10 knots coming out of the west or southwest. And if you see that red line that's going left to right, that's the velocity of the wind. So you see it's right halfway between the white line and that first orange dashed line going up and down or north or south. So that's indicating the wind speed of 10 knots. Now, as we go up here, these are the winds aloft. So that first, this 850 line, if we follow it over, so at 5,000 feet, winds are going to be out of the northwest at about 25. So it's got two long bars and 1 5. And then you can see the red, how it's going past that first line. That's indicating about 25 knots. So we'd have a pretty nice tailwind at 5,000 feet. 7,500 feet, it gets even more, looks like about 30 knots. So that would make for a nice quick flight down to Orlando. But just looking at this real quick, tomorrow at 21Z, it looks like we're going to have clear skies and winds out of the southwest at about 10 knots. And so there's the cloud height, and there is the wind speed. Now, the temperature, if you see these negative 40, negative 30, negative 20, negative 10, and 0, that's the temperature. So let's just say, for instance, this 0 here. So this little blue line that's going up towards the northeast, that's showing the temperature line. So anything left of that line is going to be freezing conditions. So if we have the red line and the green line coming together and it is left of that blue freezing line, then we could certainly have icing conditions, especially from about +5 degrees Celsius to about -20 degrees Celsius is going to be your biggest likelihood of icing conditions. So as instrument rated pilots, that's going to be important information to us, determining, okay, well, is there going to be icing in the clouds? And it makes a really big difference whether, are we just going to climb through a very small layer that might have icing, but above it, it's going to be clear and we wouldn't be in icing conditions, or does that continue all the way through altitude, which would be a definite no-go decision in a single-engine airplane. So looks like a pretty simple, straightforward Skew-T diagram here. So I'm going to close out and we're going to come down here to about Columbus, Georgia, and see what the weather's going to be like en route on the flight. And this is going to pull up Skew-T diagram. We're going to zoom out a little bit here and come over here, and it looks like sky clear again. Temperature, dew point is way away from each other, so no worries about clouds. Again, the 700 is 10,000 feet, 850 is about 5,000 feet, the 1,000 is about sea level. So we're looking right in this range, clear skies all the way up. And then the winds aloft there are still looking the same. If we're at 5,500, 7,500 feet or so, winds out of the west northwest at about 30 knots. Surface winds coming just about due west at 10 knots, as you can see right there. This temperature line, if you look, it's going kind of hard up towards the northwest, and then it stops and then goes back to the right. That's what we call a temperature inversion. Now, typically, where that temperature inversion is going to kind of act like a cap on the atmosphere. So to me, if I look at this, I'm going to kind of assume we're going to have fairly turbulent type conditions, a lot of lifting force, all the way up to about halfway between 1,850 millibars, which is about 2,500 feet. So probably above 2,500, 3,000 feet, it likely would be fairly smooth because this temperature inversion is going to kind of act like a cap and hold down any upward lifting force or whatever, just as a little tidbit. Let's scroll down here to Orlando, and I'll show you a little bit of a trick. So if we zoom into this METAR, we can type in Orlando. This is the Orlando Executive. Hit enter, and this is going to show us the Skew-T diagram specifically for that METAR location. Zoom in here. Yeah, same thing. Sky's clear. So I'm going to have to find another example. But perfect flight for tomorrow down to Orlando. Winds at the surface in Orlando is going to be out of the west, northwest at about 5. So you can kind of plan taking off in Gadsden with the winds out of the west, southwest at about 10, landing in Orlando with the winds out of the west, slightly northwest at about 5 knots there. Okay, so I'm going to zoom out. Let's find a little worse weather. Let's go to national. And just an example, I'm going to kind of show you looking through this NAM CONUS here. So we'll look through. Let's go up here for the same time, Sunday at 21Z. We'll keep scrolling. Okay, right there. So Sunday at 21Z, showing right there. Zoom in here to, let's just say West Virginia, and I'm going to click on it. If you see right there, looks like snow. which would probably not be good single engine flying weather. But let's take a peek at the Skew-T diagram and see where cloud heights are going to be. If you see here, obviously there was snow shown on the precipitation. So if you see the temperature and the dew point come together at probably about 2,500 feet or so, 2,500 to 3,000 feet, and it stays that way all the way to about, let's see here, all the way to about right there where they diverge. Now, if you look, that's going to be about 11,000 feet, so above the 700 millibars. That's going to be, over 10,000 feet. So around 11,000, 12,000 feet is going to be the top of these clouds. Because again, when that temperature dew points separate, you're not going to have any clouds. So the clouds are going to go from about maybe 2,000 feet up to about 11,000 feet, and it's going to be clear above that. Now, these clouds are going to have icing conditions existing in it. How do I know that? If we look at the temperature line, this is 0, and that blue line that's going to the northeast, okay, anything left of that, so these clouds are going to be at a temperature between about, at 2,500, it's going to be about -5 degrees Celsius, which would be prime time for icing conditions. And then at about 11,000 feet, where the clouds cease, it's going to be at about, let's kind of scroll it down here, probably -17 degrees. Once it gets colder than about -20 degrees Celsius, there's not quite as much moisture, and so your icing, your severe icing conditions would be a little bit less in that scenario. But definitely would not be flying. This to me would be known icing conditions in the clouds, snow, precipitation, so a lot of moisture there, below freezing conditions. Yeah, that's going to be icing. We can come over here, and the surface wind is going to be out of the southwest at about 10 knots or so. And I'm seeing that with the bar, the furthest down bar, and then there with that red left and right. And at about 5,000 feet, looks like winds aloft are about 35 knots out of the west, out of the southwest. So I'm going to zoom back out and just kind of showing you that where icing conditions are existing, where the clouds are. And so how cool this is with the Skew-T diagram, literally just touching your finger anywhere that you're wanting to see where the cloud height and where the wind speeds would be. So again, you can kind of see there where that precipitation would be. And then we can go here to different models, just kind of show you that. The HRR model. And I'm going to go here, make sure I'm on the latest run. If you look, I'm on the 12Z, which is not the latest run. Let me go to the 19Z run and see how many hours we have in advance. So this only goes 9 hours. So I'm going to back it up one more to 18Z. See if we can't get, okay, there we go. So now I can look at weather for 21Z on Sunday using a different model, the HRR model, which is also a high resolution data model. So I'm going to slide this thing over to 21, and you're seeing very much about the same thing that the NAM CONUS was. Maybe the HRR model is showing a little bit less precipitation. I can zoom in, push on it. And bring up that Skew-T diagram and see how it compares to the NAM CONUS Skew-T diagram. All right. So very much the same. It's showing a little more clouds here. So still showing the clouds beginning about maybe 2,500 or so going all the way up. That temperature and dew point stays pretty close together all the way through, really at about 11, 12,000 feet. It starts to separate a little bit, comes back together at around 18 to 20,000 feet. So this is showing uh, possible clouds, possible icing conditions, really from about 2,000 feet all the way up to, about 25,000 feet or so. And then if you see that 300 is about 30,000 feet, so a little bit less than 30,000 feet, it goes clear. So those are your tops. Obviously, in a single engine airplane, that's the 30,000 feet is not something we would look at. It would be right here, the 10,000 feet or less. And again, I know it's in icing conditions because I'm looking at that 0 that has that blue line going to the northeast. The -10 here has that gray line going to the northeast. And the temperature dew point lines coming together indicating clouds is on the left side of that line, indicating that it would be in icing or colder than 0. So, all right. So really, that's kind of wanted to show you how we can look at more high resolution data close to, within 2 days or so of a flight. And it really starts to get a lot more accurate with this type of model data. And then if you get bored, you can play with other things like the winter weather. I'll click on it, and you can do like total accumulated snowfall and just kind of see, and it can scroll through and show you how much snowfall you could get. A little bit slow. Okay, but there it comes right there. So you can see how that snow kind of accumulates, and it's giving you accumulations and stuff. So, but anyways, for flight planning, really to me, it's looking at the precipitation type and then determine cloud heights and determine winds for departure, en route, destination, and so forth. So hope this helps. Let me know if you've got any questions. But again, pivotalweather.com, the model data. There are so many different models there, but once we get within a couple days, I like going this convection allowing. You can also play with the regional, I'm sorry, the NAM, the rapid refresh, which is the RAP, and it works the same exact way as we looked at the NAM CONUS and the HRRR. And in the previous video, we looked at the GFS model and the European model, and that lets you go out several days in the future. But the same way, we get a Skew-T diagram by pushing on it, and also the precipitation type, we can see that. But just know, 4, 6, 7 days in advance, and especially further than that, the models are not all that accurate. So don't use that for, go, no-go decisions. Wait till you get within 12 to 24 hours looking at what we just looked at there. And that really helps you determine go or no-go decisions. And maybe you just change your plans, go a little earlier, go a little later, or whatever. So if you got any questions, let me know, and hope it helps. Thanks.